This is Algebra 2, Unit 11, Lesson 11, on the reciprocal trig functions. Now, we have seen the three primary trig functions, which are sine, cosine, and tangent. Now, each of these can be defined in terms of the ratio of the sides of a right triangle or on the unit circle. So we know SOHCAHTOA for those. All right, however, there are other functions that go with them. They exist what are known as reciprocal functions. So their definitions are shown here. Okay, so we have cosine. Well, the reciprocal of cosine is called secant. Secant theta is equal to 1 over cosine. Cosecant, CSC here, is the reciprocal of sine. Cosecant of theta is 1 over sine theta. And cotangent is the reciprocal of tangent, which is 1 over tangent theta. Now, since we know that tangent is sine over cosine, cotangent will actually be cosine over sine. So those are the three you need to know. The reciprocal of cosine is secant, the reciprocal of sine is cosecant, the reciprocal of tangent is cotangent. Okay, but by working with sine and cosine, we can figure these out pretty easily. All right, so the secant of 60. Let's figure out the answers in exact or simplest form. The secant of 60, we know secant is 1 over cosine, so this is going to be equivalent to 1 over the cosine of 60. All right, now what is the cosine of 60? Well, it's 1/2. If you remember from the unit circle, or if you memorize those values, it's 1 divided by 1/2. So that's 1 times 2 over 1 when you do the reciprocal. So that's going to equal 2. Okay, the cotangent of 150. All right, now we know cotangent is 1 over tangent of 150. All right, and now tangent is sine over cosine. So cotangent will be cosine theta, or cosine 150 in this case, over the sine of 150. So instead of being sine over cosine, it's going to be cosine over sine. All right, so the cosine of 150. All right, now remember 150 is in the second quadrant, like so. Its reference angle is going to be 30 degrees. So in the second quadrant, cosine is negative. What's the cosine of 30 degrees? It would be negative square root of 3 over 2. And sine in the second quadrant is positive. So the sine of 30 degrees is 1/2. All right, so negative square root of 3 over 2 divided by 1/2 would be times 2 over 1 when you do the reciprocal. These cancel, and cotangent of 150 will equal negative the square root of 3. All right, cosecant of 3 pi over 4. All right, well, first of all, what is 3 pi over 4 in degrees? Well, I would convert this to degrees. 3 pi over 4 times 180 over pi. That cancels the pi's out. And then 4 goes into 180 45 times, and 3 times 45 is 135. So we're looking at 1 over the cosecant of 135 degrees, or 3 pi over 4. Okay, or 1 over sine, I'm sorry. Cosecant is 1 over sine. All right, so 135, again, is in the second quadrant, which is over here. The reference angle will be 45. So sine is positive in the second quadrant, so this is going to be 1 over the square root of 2 over 2. Okay, so if we want to simplify this, it's 1 times the reciprocal would be 2 over the square root of 2, which is 2 over the square root of 2. Now, we don't like to leave radicals in the denominator, so we're going to multiply by the square root of 2 over 2. So that's going to be 2 square root of 2 over 2, and then the 2's cancel, just leaving the square root of 2. So there we go. Okay, so all you have to do is the same thing we've been doing, except you have to do its reciprocal. You have to do 1 over. All right, which of the following is closest in the value of secant of 52 degrees? Okay, well, we know that secant is equal to 1 over cosine. So this is going to be 1 over the cosine of 52. All right, so cosine of 52 I can put in my calculator. I just have to make sure my calculator's in degree mode. All right, so I want to do 1 divided by the cosine of 52. Close your parenthesis. Is approximately 1.62. So that is going to be number 2. So that's about 1.62. Okay, so all we had to do was know that secant is 1 over cosine. All right, because each of these reciprocal trig functions has a variable denominator, there will be angles at which these denominators are 0, and hence the function is undefined. So which of the following values of x is not in the domain of y equals cosecant of x? All right, now remember, cosecant is y equals 1 over sine of x. All right, now let's think about the unit circle for a second. When is sine of x equal to 0? All right, when is the y coordinate equal to 0? On the unit circle. Well, let's see. Let's think about 180 degrees. All right, so we have 180 degrees would be over here. That is the coordinate point -1, 0. So that means the y coordinate will be 0. So if I do 1 over 0, that's going to be undefined, so that won't work. All right, the rest of them should work fine. If I look at 60 degrees, I know that 60 degrees for the unit circle for the sine is going to be the square root of 3 over 2. So if I do 1 over the square root of 3 over 2, that's going to be a number that's going to work. It's going to be an irrational number, but it'll work. 90 degrees would be right here. That coordinate point is 0, 1, so that's going to be a value of 1 over 1, which is 1. And then 135 would be right here with a reference angle of 45 degrees. That has a value square root of 2 over 2. In the second quadrant, it's positive, so it's going to be 1 over the square root of 2 over 2. So it's going to be number 1 because that'll make that 0, and that makes that undefined. Okay, so this is number 1. All right, because each of these functions is dependent on sine or cosine, it is possible to determine the sign, either positive or negative, of each of the based on the quadrant of the input angle. All right, so we learned ASTC to remember this. So let's take a look at all our values when we do this. Okay, so let's look at cotangent of B for B in quadrant 2. All right, now we know that cotangent is going to be, instead of sine over cosine, it's going to be cosine over sine. So it will be cosine of beta over sine of beta. All right, cosine of beta in second quadrant, cosine will be negative, sine will be positive in the second quadrant. So negative divided by positive will be negative. Okay, and if we look at our, remember here, sine is positive, so that means that tangent and cotangent will be negative. All right, secant of B. Secant, remember, is 1 over cosine. So 1 over cosine of B. All right, so if I'm in the second quadrant, this is going to be 1 over, or the fourth quadrant, I'm sorry. The fourth quadrant will be positive. So 1 divided by a positive number will be a positive number. So if cosine is positive in the fourth quadrant, secant will be 2. Okay, cosecant B, beta for beta in quadrant 3. All right, if we look at quadrant 3, cosecant is actually 1 over sine. So it's 1 over sine beta. All right, so it's going to be 1 over, what is sine in the third quadrant? It would be negative. So it's 1 over a negative. 1 divided by a negative will be a negative. So it's going to be negative in the quadrant, in the third quadrant. All right, so if we remember ASTC, what we have here, if cotangent is negative, tangent will be negative. If secant is positive, cosecant will be, or secant is positive, cosine will be positive. So what we have is secant has the same signs as cosine. So this will be positive in the first and fourth quadrant. It'll be negative in the second and third. For sine, cosecant is same sign as sine. So if you are in the first or second quadrant, sine will be positive, and cosecant will be positive. If you're in the third or fourth quadrant, sine is negative, and so is cosecant. So tangent, for the same idea, tangent is positive in the first and third quadrant, and negative in the second and fourth. So cotangent will also be. So the reciprocal functions are positive and negative in the same places they are as the original sine, cosine, and tangent functions. All right, so let's look at exercise 5. If cotangent theta is less than 0 and secant theta is greater than 0, then theta would be which of the following angles? Okay, so let's take a look at this. Cotangent is the reciprocal of tangent. All right, tangent is negative in the second quadrant. If we go ASTC, tangent is negative here and also negative here. Okay, secant would be the same signs as cosine. Cosine greater than 0 will be cosine is positive in the first quadrant and here. So where does it work for both of them? It would have to be the fourth quadrant. So which one of these angles falls in the fourth quadrant? Well, it would be number 2. So there we go. So if you know where everything is positive and negative, you can pick out your values pretty easily. Now, we should also be able to produce all of the trig ratios, all 6 of them, sine, cosine, tangent, secant, cosecant, and cotangent, if we're given a right triangle. So a right triangle is shown below with the sides of length A and B. Find the length of the hypotenuse in terms of A and B. Label in the diagram. All right, so the hypotenuse, we can use the Pythagorean theorem, A squared plus B squared is equal to the hypotenuse squared. So to solve for H, we take the square root of both sides. So H is going to equal the square root of A squared plus B squared. Okay, so they're in terms of A and B. That's what we have. All right, so state the value of each of the following trig ratios in terms of the constants A and B. All right, so remember SOHCAHTOA. Okay, so sine is opposite over hypotenuse. So that's going to be A over the square root of A squared plus B squared. So what would cosecant be? Well, it would be the reciprocal of this. So we'd flip it. A squared plus B squared over A. Sine, cosecant are reciprocals of each other. All right, cosine of A is adjacent over hypotenuse. So it's going to be B over the square root of A squared plus B squared. So secant will be the square root of A squared plus B squared over B. Okay, these are reciprocals. And then tangent would be opposite over adjacent, which would be A over B. So cotangent will be the reciprocal, which is B over A. So there are all of your values. Okay. All right, let's save the last one for the next lesson. All right, so if alpha is an angle whose terminal ray lies in the fourth quadrant and cosine A equals 1/3, then determine the exact value of cosecant A, show how you arrived at your answer. So we'll work on this one in the next class, see if you can figure it out on your own.